Good morning, everyone. Today I'll be speaking on cyclotron. So, what is cyclotron? Cyclotron is a machine that accelerates charged particles or ions to high energies. It was invented to investigate the nuclear structure by E.O. Lawrence and M.S. Livingston in 1934. Both electric and magnetic fields are used in the cyclotron to increase the energy of the charged particle, as both the fields are perpendicular to each other. They are called cross fields. In a cyclotron, charged particles accelerate outwards from the center along a spiral path. These particles are held to a spiral trajectory by a static magnetic field and accelerated by a rapidly varying electric field. Working principle of cyclotron. A cyclotron accelerates a charged particle beam using high frequency alternating voltage, which is applied between two hollow D-shaped sheet metal electrodes known as the Ds inside a vacuum chamber. The Ds are placed face to face with a narrow gap between them, creating a cylindrical space within them for particles to move. Particles are injected into the center of this space. These are located between poles of electromagnet, which applies a static magnetic field B, which is perpendicular to the electrode plane. The magnetic field causes the path of the particle to bend in a circle due to the Lorentz force perpendicular to their direction of motion. An alternating voltage of several thousand volts are applied between the Ds. The voltage creates an oscillating electric field in the gap between the Ds that accelerates the particle. The frequency of the voltage is set to that particle make one circuit during a single cycle of voltage. To achieve this condition, the frequency must be set to the particle's cyclotron frequency. Application of cyclotron. Cyclotrons are much more effective than linear accelerators because cyclotrons accelerate the particles several times in a single setup due to the cylindrical shape. Less shape is required as compared to linear accelerators. Some of the uses of cyclotron are listed below. Cyclotrons are widely used to accelerate charged particles in nuclear physics experiments and use them to bombard atomic nuclei. For radiation therapy in the treatment of cancer, different cyclotrons are used. Cyclotrons can be used for nuclear transmutation, change of the nuclear structure. Limitations of cyclotron. Neutral particles, example neutron, do not interact with electric or magnetic fields, so cyclotrons cannot be used to accelerate them. Since electrons have very small mass, their speed increases very rapidly, and soon the resonance between the high voltage and the particles becomes lost. Hence, a cyclotron cannot accelerate electrons. Cyclotrons can accelerate particles to speeds much less than the speed of light in the non-relativistic regime. Cyclotron frequency expression. F is equals to qb by 2 pi m. The magnetic field strength is denoted by the letter B. Q is the particle's electric charge. M is the relativistic mass of the charged particle. Particle energy. Each time a particle crosses the accelerating gap in a cyclotron, it is given an accelerating force by the electric field across the gap. And the total particle energy gain can be calculated by multiplying the increase per crossing by the number of times the particle crosses the gap. However, given the typically high number of revolutions, it is usually simpler to estimate the energy by combining the equation for frequency in circular motion. F is equals to V by 2 pi r. With the cyclotron frequency equation to yield V is equals to Q V R by M. The kinetic energy for particles with velocity V is therefore given by E is equals to mv squared by 2. That is equals to Q squared B squared R squared by 2m, where R is the radius at which the energy is to be determined. The limit on the beam energy which can be produced by a given cyclotron thus depends on the maximum radius which can be reached by the magnetic field and the accelerating structures, and on the maximum strength of the magnetic field which can be achieved. Some interesting facts related to cyclotrons. To accelerate particles with relativistic speed, synchrocyclotrons and isochronous cyclotrons are used. These modifications are made to balance the increasing mass of the accelerating particle as its speed tends to the speed of light. Ernest O. Lawrence invented the first ever cyclotron at the University of California, Berkeley in 1932. It was a 69 cm diameter machine with a maximum energy of 4.8 mega electron volts. He was awarded the Nobel Prize in 1939 for this invention. He also invented synchrocyclotron in 1945. The largest cyclotron is at Triumph Canada's Particle Accelerator Center, which has a diameter of 80 meters and maximum energy of 520 megaelectron-volts. The superconducting ring cyclotron SRC can produce high-intensity beams of accelerated particle at RIKEN, a large research institute in Japan. There is an SRC of 90 meter diameter. It has 6 superconducting sectors. That's it for today. I hope you would have enjoyed the video. Thank you and have a nice day.